Okay, all right. Now it's my great pleasure to introduce our second speaker, Matt Miesnieks. Matt is a senior entrepreneur with more than 15 years of experience working at the intersection of computer vision, spatial computing, and applied AI. He previously led business at Lyre, one of the earliest augmented reality platforms, and later co-founded 60.ai, a company that pioneered the concept of AR cloud, enabling mobile devices to reconstruct and reason about physical spaces in real time. After its acquisition by Niantic in 2020, 60.ai's technology became part of the infrastructure behind large-scale AR mapping. Today, Matt leads a flagship product for computer vision developers with a focus on predictive world models and next-generation scene understanding tools. He is also a frequent speaker and writer on spatial computing, physical AI, and the future of machine perception. We're very honored to feature Matt today. Please welcome him.
Thank you. Yeah, I've spent like 15, 16, 17 years or something now working in this space, and I loved how the theme of this event was from pixels to voxels. My last company, 60.ai, was all about turning the world into voxels, and Niantic is doing an amazing job of doing that. However, the theme of pretty much everything I've worked on over the years has been, what are the things holding XR back, AR back from the sci-fi experience that we all kind of imagine? And voxels aren't enough. You know, you can capture the whole world, but ultimately you've got to really start to understand what the world means. Like, you've got to be able to understand the world the way we are. And the question now, and it's a very exciting topic in AI in general, is this idea of world models. And I want to use this talk to sort of answer the question. It was like, will world models make XR happen? And the answer, to give you a jump ahead, is no and yes. I'll explain why. XR or AR has been it's a pretty simple thing. We just need to have these devices that can sense and perceive the world, you know, take all the sensory information in. Then we just need to figure out, understand what it all means, you know, and understand ourselves, and then it improves our lives. It sounds pretty simple. But although the sensing the world and seeing the world is, I don't know if it's completely solved, but we've got amazing devices, amazing sensors that's on the way to being solved. When it comes to understanding, we're kind of at this point. Don't know if people have seen this scene. I don't know if you've tried any of these AI glasses or XR glasses and said, tell me what I'm looking at. We're barely beyond the point of being able to tell is it a hot dog or is it not a hot dog? They can't really understand what they see. The best models, the best systems out there, they can recognize more than hot dogs, but it's pretty much just a long list of objects that they can recognize. They don't really understand. And beyond that, they really only understand things where there's text associated with that in its training data. The good news and the bad news around AI is it has changed everything. It's obviously fundamentally changed how we work. It's, you know, sparked this insane boom. But what AI means today is large language models, not just chatbots. Like, everything today is a language model to some extent. It's based on a generative AI architecture, and they start by, you know, predicting the next token. So when that comes to a chatbot, it predicts the next word. You know, if you saw Avi's talk earlier, it predicts the most probable next word that's going to come. So when you've got text, in English, there's 150,000 or so English words. You need a lot of data to predict that. Then we started to get image models, and you're starting to predict every pixel on a screen, where each pixel is a token. The models needed more data, more training, more compute. They're more expensive, but they work pretty well. You then get into video models, like Miesnieks was just showing us. Again, you now have the pixels, but you have number of frames per second, and you've got to understand, you know, frame to frame what those pixels mean. Again, more data, more training, more compute. And then we're getting to now, you know, these world models. And when people talk about world models in this context, or 99% of what people talk about, is this idea of a video model, but it generates immersive 3D video that is physically correct over time. So if you walk around that space, it doesn't jolt around, it doesn't change from frame to frame. If you hit something, it behaves, like a game engine would behave. And they take even more data. They take, as well, everything that video data needs, plus all of the physics data about the world, and then when you want to get them into understanding, the real world itself, you go from like 150,000 or so English words to train on to everything that might possibly happen in the entire physical world at any point in time to try and predict what's next. And you get this problem that is an infinitely large vocabulary of things to try and train your language model on. And these models get so big and so expensive, and they still really don't capture everything. And you then get new industries rising up to try and solve corner cases through like reinforcement learning or simulated data, or trying to think of all the things. And that's how successful products today, like Waymo cars, are kind of trained with this approach, but it's not cheap, and it's not something that's going to run in my glasses anytime soon. The bet that everyone's making is this idea of the bitter lesson, which is that we all think there's a smarter way to do something, but it turns out if you throw more data and compute at it, it kind of solves the problem. And that's held, all the way through this, approach so far. So that's kind of the state of the world today. The real question, though, is almost philosophical, and it gets back to the term language. That word and that approach is the question that we really need to be thinking about, and it's the question that is really at the forefront of AI research right now. Can we understand the world without language? Is language enough to understand the world, in and of itself? Language models are trying to say, yeah, if we just have language, if we just have these tokens that represent things, we can figure out how they all connect to each other, and language is enough. But this has been a philosophical question for a while, and a philosopher called Martin Heidegger, pushed this idea that language is actually a reflection of reality. It's not the understanding of reality in and of itself. And it's the idea of, I think Avi mentioned a hammer before, but can you actually understand what a hammer is just by describing it and the words around it? Or in order to understand what a hammer is, do you actually need to pick it up and hammer something with it? And the belief that I have is that second approach, that you need to actually have a direct conceptual understanding of something to actually understand it, is what we need for models to be able to understand the world, not just a linguistic description of them. So it's kind of fun as an entrepreneur that philosophy is actually starting to become our roadmap at the moment. These aren't like theoretical abstract conversations anymore. They're actually like, look, what are we going to build, and what's the algorithm, and how does this stuff work? But it's gotten really fun, especially if you've come from a XR background, in that we do need a totally new type of AI company, a whole new approach to building AI. It needs to be different in how it learns. It needs to be different in what it outputs. But let's also call it a world model. Let's call it the same thing as these other models. But this is now a predictive world model. So for everyone who's been around XR for a while, we all love this idea of, is it XR, MR, VR, AR, spatial computing, mixed reality, like all these words that kind of mean the same thing. When you hear the word world model, just think of it as XR for AI, in that it's a vague term that people apply it to be whatever they want it to mean. But what I'm talking about is a very specific thing. It's this idea of a predictive world model. And what that means, first talk about generative world models, what they mean is predicting the pixels of what comes next. They're like a video model, but in that the output of these models is more video. The video that's consistent with how the world works. That's pretty much all they output by design. And they are good for a few things. They're good for, maybe turn out to be good for entertainment, for gaming, film, all that sort of stuff. Jury's still out there on whether that works, but seems to be there. But the thing where they are gaining traction is for creating simulations. So you can tell your world model to create a real-world scenario, and then you put your virtual robot into this virtual scenario, and you train it on the simulated data. And that's why I showed this idea of a snake eating its tail. They're building these models to create more data, to train virtual devices which feed back in to create more data, and trying to solve that problem of simulating and training on the entire world. I don't believe that's tenable, and more and more people in the AI research community are kind of swinging around to that point of view. The type of world model I'm talking about is this idea of a predictive world model. The technology, the approach underneath it has been largely invented and definitely championed the most by Jan LeCun, who was recently head of AI at Facebook. He's just started a new startup called AMI with about $1 billion in seed funding. And the technology is called a JEPA, if you want to look up, J-E-P-A, and it's a new way of training. And the metaphor is that instead of learning pixels about the world and how these pixels are represented and sort of matching and predicting the next pixel, it learns concepts. It learns directly in the latent space of the model. And that is very, very similar to how babies learn. If assume everyone's at least seen a newborn baby, they just kind of sit there with no language, no ability to communicate, and they just sit there and they watch the world. They're effectively watching videos of the world. And over time, they see things enough times. Maybe the family dog comes into the room enough times, and they sort of get the idea that that's a thing that I recognize. And I get the idea of how it behaves in the world. I get what it can do and what it can't do, and I recognize it, even though I don't even know what words are. I just have this representation of a dog and the physical attributes, the conceptual attributes of it. And it builds this model, not just of what things are, but of how they behave, and also of how the physical world behaves. So if you've ever played peekaboo with a baby, at some point in its development, when you cover your eyes, you're gone. The baby thinks you've disappeared, and then you show your face, and it's like, oh, I'm back. And it's funny, it's exciting. You're gone, you're back, you're gone, you're back. And then one day it realizes that, hang on a minute, you're still there the whole time. You've never left. It gets this idea of like object permanence. Things are there even if I can't see them. And that type of learning is a very different way of learning to the way language models learn, whether it's video, world model, whatever. The difference is in something like a self-driving car. It might be going down the street, and there's a truck parked on the side of the road, and a kid comes down a driveway on a bicycle. The car will see the kid, it'll recognize there's a kid coming on a bike, and then the kid goes behind the truck. They're out of sight. For that period of time, in the language model's mind, that kid does not exist anymore. They've gone, they've played peekaboo, it's disappeared. And then it pops out again in front of them, and then they've got that fraction of a second from when they reappear to react. Where a JEPA-style model, which understands this idea of, intuitively understands the idea of object permanence, will say, oh, just because they were moving, they were really there, but just because I can't see them doesn't mean they're gone. I can predict that they're about to come out from behind the truck. And so the device, a car in this point, is able to have an ability to predict what's about to happen next in the world through this intuitive understanding of what things are, how they behave, and how the physical world works. That's kind of the fundamental difference in learning. Additionally, they learn at a higher level of abstraction about the world, in that if I asked any of you to think back about your childhood home, where you grew up, everyone will be able to remember that. But in our minds, we don't have a pixel-perfect 3D image of that home. We just have a bunch of concepts, maybe what our bedroom was like, what it smelled like, cooking in the kitchen, but there are all these conceptual ideas that don't take up a lot of data. Where if you asked a language model to say, hey, show me the house I grew up in, it would generate every single pixel, right? And that takes both a lot more inference compute to generate that, as well as more data to train, because the JEPA models are only remembering and storing and training on these concepts, which are like a compression of reality into a conceptual form. So the models are not only cheaper to train, they need less data to train, they're much more efficient in their inference, so they can run on much lower power hardware. So that's all really good, but then there's one piece missing that, like in this image, you have all this conceptual understanding, but you still need to be able to communicate with it. And that's where language models come in. Like you train a language model to sit in front of a JEPA model, and that lets you have like input and output to the brain, to the world model. And that's the piece where it's the combination of the two where we think things get really, really interesting. Because you could take in image from a camera, you could take in words, you could take in sounds through the language model, then map them to the concepts and have some sort of understanding of what's going on, and then communicate that back, to either back to the robot system or back to a person. So what does it mean in terms of XR? And I put an asterisk next to XR. These world models are really going to change how everything in the world, every device that is in the world works. I mentioned self-driving cars before. That could be a robot. It could be a humanoid robot, a dog robot, a vacuum cleaner in your house. It could be the drones that are flying around doing all sorts of stuff, as well as glasses that need to understand what they see in order to then communicate back to you through some content on your display or through some audio feedback or something like that. The really cool thing, and this is a problem that we wrestled with for years and years at 6D, when that idea of being more robust, it's just two little words, but anyone who's worked with computer vision in any way knows how easy it is to break those systems. You can get them working in a narrow environment that, they recognize hot dogs, and then you show it a hamburger and it breaks. That could be for robots, you take it out of the factory that it's trained in, it breaks. You put it in at nighttime, it breaks. It rains, the model breaks. Like all this stuff to get a general understanding of the world that works anywhere is a really, really hard problem to solve. It's why a really difficult problem for robots today is crossing the street. It's something that like a 5-year-old kid, you show them like maybe 10 times and then they know how to cross the street. A robot with God knows how many billions of dollars and hours of training, whatever, still can't do that. Or maybe it can cross the street in one place with just at the crosswalk, but if you drop that into a different country with different traffic laws and dirt roads instead of tarmac roads, it's lost. The difference is the child has a conceptual understanding of what a road is. And it doesn't matter whether it's a particular sidewalk here in Cambridge or a dirt road in Africa or some beach track near where I grew up in Sydney. That conceptual understanding means that the systems can understand things irrespective of the background, irrespective of the environment. It understands, it recognizes the concept. It's something that Avi also touched on before with LLMs, how they recognize that. He showed you the machine with the balls, where it always picks like the most likely thing. JEPA learns the other way around. It learns what is normal and then pays attention to what's unusual. It's exactly the way a baby, I talked before, sitting in its crib, it's looking at the room, a dog walks into the room for the first time and it'll startle and go, oh, what's that? And all of its attention goes onto that. It's exactly how we learn. If I'm on a video call and there's just my background behind me, you're chatting away, and then a clown walks behind me, all of your attention is going to go onto this weird thing, this outlier thing that's happened. JEPA learns the same way, and again, it's more about how the real world works. We want our devices to naturally pay attention to what is outlier situations. I mentioned how they're smaller. The big thing of this, the end result of all of this is that these models will run on our devices today, on our hardware, and they have this general understanding of the world. That ability to run on your device it's everything. No one wants your Tesla to be calling back to the cloud to check if it's safe to change lanes. These things have to happen in real time. Our view is that the AGI future that we're all going to hopefully get to one day will split roughly into like type 1 and type 2 thinking, where the type 1 quick decisions, how do I move around the world, how do I do simple things, how do I achieve tasks, That will all be done with on-device AI. That's small, real-time, conceptual. All of the pondering, all of the planning, all of the big decisions, all of the thinking through and researching things, that will all be passed off to the cloud and handled by these giant frontier models that run in the clouds. So where are we today in all this direction? These generative world models are what people mean today when they say world models. They're getting billions of dollars in funding. They are generating cool models. There's companies like World Labs that are doing some great work. Luma, Google, OpenAI, they're all building these interactive 3D worlds that can be prompted. There's some products coming on the market. It's kind of happening now. Question is, like, will it actually accomplish the big goals? Where predictive world models are just getting attention right now. We can recognize objects, we can recognize actions, starting to recognize intuitive physics, but the next exciting thing is how do we start learning the relationships between things? A dog can walk, a dog cannot drive a car, people can be friends, all these types of things are sort of still the interesting part of building these models of how the world works and where things get really exciting and philosophical quickly. So my bet, if you ask me, what to do, what am I doing, where am I putting my time and money and energy right now? The bitter lesson, even if it's right, it's still wrong. In that even if it does achieve all this understanding of the world, the way of achieving it with more and more data and more compute disqualifies it from the fact that it has to run on device. Very low power devices, low compute, low wattage. They'll never ever, that approach will never ever solve the problem of this on-device type 1 thinking about the world. I think that predictive models are going to be what makes XR happen. It's going to be what makes robotics happen, what makes a lot of these smart devices actually become useful in a step function way, in the same way that ChatGPT made text useful and interactive. And to back that, I've started a new stealth company. It's called Primate Intelligence, and we're building these models for a JEPA-based predictive world models to run on devices. And the reason we called it Primate Intelligence is summed up by this great quote by the head of robotics at NVIDIA, is that, and this quote came out after we named the company, so I was quite happy to see that, is that there already exists that question about can we understand and interact in the world without language. It's already been proven that there is an existence of that, in that primates, apes, they have a very sophisticated ability to act in the world, no real tiny ability, with language. So we want to solve that problem of enabling, building this type of AI that can understand the world in the same way that primates can, and let other people solve the language approach. That's it. Thank you. Happy to take questions if we have time.
Maybe one question.
Thank you. I worked for LeCun in 2017, and I was wondering what he was up to. But do you think that enough is understood about human consciousness and human learning to build a model to train an AI?
No. I think that AI is its own thing. It's not we're not trying to build human consciousness in silicon. It's going to be something that behaves similarly to how conscious humans behave, but whether we can say it's actually conscious, I mean, the example is like half of all of us, majority of our decision making comes from our gut biome. That drives us in the things we do. It isn't something that happens in our brain. We have barely comprehend like how we actually understand and act as biological creatures. And AI, like silicon machines, will never ever be that. So they're always going to be something different. I think about it as, can they be useful, and can they do things that help us, and can we've evolved to act and interact with the world in ways that suit us. Like the built environment is all set up for our biology. if we can come up with machines that can function in that environment, then hopefully with that power and applied responsibly, like we can come up with devices that help us in lots of ways. But the question of can AI replicate human consciousness, I just think it's apples and oranges. You know, I don't think it can ever do. So, but I'm guessing. Everyone's guessing. Like, I don't know. You know. Yeah.
Just a quick question. So what's your take on potential applications for multi-sensory world models? Like if you were to really think about human applications of touch, olfactory,
Yeah.
other.
We are starting with just the sense of vision, like computer vision. You know, we're training it based on what it sees. Obviously, the idea of like multimodal input and sensory is huge. Like if you want to, I don't know, control a humanoid robot, you want it to not just understand maybe audio commands, but in audio context, you want it to be able to understand like force and gripping and motion and all of these types of inputs, you know, not even just like human inputs, like you could take like multispectral imaging, for example, and see into infrared and all this stuff. The models, it's not that big a deal to, you know, take them as inputs and train the model in a multimodal way. What the science project is that no one's really understood yet is kind of alluded to before. Like we understand sensing, we understand like objects, we starting to understand actions in the world, but the relationships between things. Like we can, you know, a dog can't drive a car, a dog can run, a dog cannot fly. That's all straightforward. But when you get to sort of like what's right and wrong, like when I walk into a room, what should my model pay attention to versus what should it not pay attention to? Like a fireman will pay different attention to things than a chef would when it walks into a room. So those type of questions around taking all that input and then making good judgments about what the model should, you know, pay attention to is like that's the sort of fun ideas to think about that not even in research has really got clear ideas on how that stuff's going to play out yet. That's next.